Hi, I am Aprajita from Team 17 and we have developed a language called ORION for our SER 502 project. So these are the team members of Team 17, Yuvan Pradeep, Aprajita Thakur, Ankita Shivanand. So in this presentation, I'll go through all these contents, firstly starting with the introduction, then the features of the language, components, grammar, tokenizer, parser, evaluator, and lastly we'll execute some sample programs. So we have designed an imperative language called ORION, and this language allows us to perform some sequence of operations like selection control structure, where there is a statement which is executed depending on the state of program, like if statement, if then else statement, iteration control structure, which will allows us to execute statement until the condition is true or false, like while loop. It also allows us to declare the data types of variable, declare the types of variables which you want to use, and assign the values to them. So the features of the language ORION is it supports digits from 0 to 9, alphabets A to Z. It has data types int and bool, which is integer and boolean, conditional constructs like if then else, if then end, and looping constructs like while loop. Now the more features of ORION are assignment statements. Is allow us to assign the value of an expression to an identifier, and also allows to assign a value to a identifier. Conditional operators, which includes equal to, greater than or equal to, less than or equal to, and not equal to. Arithmetic operators like addition, subtraction, multiplication, and division. The additional feature in our language is ternary operator, where the syntax is Boolean expression followed by block 1 and block 2. If the Boolean expression is true, it will evaluate to block 1, otherwise it will evaluate to block 2. Now we have 4 components of ORION. Firstly, I'll start with the tokenizer. Tokenizer, what it does, it will take the file where we have written our program. It will convert the program into list of tokens, and it will pass to the parser. The parser will generate a parse tree, and that is the intermediate code for the language ORION. The parse tree will then be passed to the evaluator, and there it will be evaluated, and finally the output will be displayed in the evaluator. This also contains a symbol table where we have 2 operations like lookup and update. The lookup will look for the variable in the existing environment and return its value and data type, and update will update the value of that variable in the environment, returning a new environment. Now this is how our grammar looks like. It starts with the program, where main is the starting with small parenthesis, then it is followed by a block is followed by a declaration inside curly brackets. Then these are the different types of declaration. It also includes commands followed by declaration and ternary expression. It also has ternary expression, which is again like Boolean expression, and then block 1 and block 2. Boolean expression, which will be a Boolean expression in the small bracket, or it can be an arithmetic term with some operator in an arithmetic term again, or it can be normally true or false. Now arithmetic term can be plus, minus, and term is further divided into star, that is multiplication and division, because multiplication and division has the highest precedence. Now identifier is again divided into number and alphabets. This is the command, which is if then, else, and if then statement. It also includes while, Boolean expression, block. These are the operators which we have used in the language, and the number is again further divided into digits, and digits are from 0 to 9, and we have 2 data types like int and boolean, and these are the alphabets A to Z. So the constraint of this language is that it only allows single digit, and we can't assign multiple digits to a variable. So now my teammate Ankita will help you with the tokenizer. She'll explain the tokenizer.
Hi, I'm Ankita. I'll walk you through the tokenizer and parser for our project. Now I'll walk you through the tokenizer. Basically, what tokenizer does is breaks down the input program into individual tokens by eliminating the extra spaces. Here, the whole program is broken down into a list of identifiers, keywords, and numbers. So, overall, the process followed here is it reads the input program file as a stream of bytes, and then we eliminate the spaces and the new line characters on the basis of its ASCII code, and we return the list of tokens. So, the final output of the tokenizer would be the list of tokens, as you can see here below, with comma separated. So, how it does this, I'll walk you through the code. We have a main program. In the main program, there is this tokenize which takes file name and file name as input and gives us tokens as output. So, in the tokenizer.pl, what we have is first we take the file name as the input, and then open and read commands are used to read the file, and then we have clean token space predicates to eliminate the spaces on base of the ASCII values, and it also eliminates the new lines, and it differentiates between the identifiers, numbers, and keywords. So if you see here, this is the predicate to which eliminates which identifies the identifier, numbers, and keywords, and here we have clean token space predicate again to eliminate the spaces and new line characters on base of the on the basis of its ASCII value. So the output of this tokenizer will be the list of tokens as we saw in the as we saw before. So the list of tokens is later being passed to the parser. Now what parser does is it parses the generated list of tokens from the tokenizer and gives us the parse tree as the output. It creates a parse tree basically. So we have used here definite clause grammar to write the parser program, and the grammar file will look like something orion.g4, and the output of the parser program will be the parse tree, something like this program. How parser works is like I said before, this parser takes the tokens as a list of tokens as input and generates a parse tree, and we have used definite clause grammar to generate the parse tree in Prolog. So how it works is each of the tokens, they are treated as nodes here. So we have definitions for how a program will look like. So program should have a main with open and close parenthesis and will contain a block, and this block will contain flower brackets with the declaration in between. So we have definitions for each of it, how a declaration should look like, and we have also implemented the while, if then else, and we have boolean expression definitions, arithmetic term which will take plus, minus, multiplication, and division. So based on these definitions, a parse tree gets generated. So if the input program that is being provided is satisfies the grammar, then the parse tree gets generated. Only then the parse tree gets generated. So we have terminals as well here, digits, which takes values from 0 to 9, and alphabets which takes value from A to Z. So this is our parser, and it generates a parse tree which will look something like this one. The output will be the parse tree, and this is being further passed as an input to the evaluate program, which evaluates our program and gives us the final output. And now my teammate Yuvan will explain you about the evaluate program.
Hi, this is Yuvan. I'm going to explain the evaluator of our language ORION and also how to execute few sample programs. The main purpose of the evaluator is to evaluate our input program and display the output. Basically, it has two input arguments. One is the pass tree, which is coming from the parser, and another one is the tokens, which is coming from the tokenizers. So we have other operations like symbol table, lookup, and update operations. Symbol table is to create an environment, and we'll be using the environment through the entire program. The environment contains identifier, value, and its data type. Lookup is used to look for an existing value in the current environment, and update is called to update a value in the environment. I will walk you through the evaluator of our language ORION. In evaluator, we have the symbol table, which will get tokens as an input and produces an environment. And the eval program will get the pass tree and the intermediate environment as an input and produces the final environment. We have written predicates for each and every statements based on the grammar. Main purpose is to reduce the bigger one into the smaller components by using reduction rules. For example, in arithmetic operation, we will be looking for the arithmetic plus in the pass tree. So after that, we will get the value and the corresponding data types, and we will be performing the arithmetic operation over the values and return the value to the same. After that, an update operation will happen and it will update the environment. So it will be done in a sequence way, and our final environment will have the final identifier and value pair. So after our final environment, we will be perform the lookup operation over the final environment, where we will be searching for the variable x. X is our output variable in our language. Now I will show the basic structure of our language, how the program will looks like, and this is our pass tree, which is the intermediate code in our language. Now I will explain the execution of the program. In order to execute the program, you need to download the Swiss Prolog either in Windows or Mac. To execute our program, we need to keep our sample programs in the source folder. I already kept the sample programs in the source folder. I'm going to execute few of these programs. Before doing that, you have to open the terminal and go to this particular source directory, and you need to perform swipl to check whether the Swiss Prolog is installed or not. Yes, it is installed. Now in order to compile our main program, I am doing consult ORION underscore main, which is our main program. So I just compiled the main program, it is executing fine. Now in order to execute the particular program, which is the program 4, here I am trying to check two if blocks. So if the first if block is returns true, it will go to the inner if blocks, and if it is true, then it will execute the x equal to 7. And basically x is our output variable, so in this program x equal to 7 should be our output. In order to run this program, I have to perform pass tree to get our intermediate code, and the output is our final output. So now our intermediate code got generated and our expected output is 7, which is working fine. Now I will show you some of the different programs which is to perform the ternary operator. Here A and B are declared, and if A is less than B, we need to perform x equal to 1, and our output expected output is x equal to 1. So I'm just changing the program name to 5 and performing. So this is our intermediate code which got generated, and our expected output is 1, which is executed perfectly. And I will show you one more program which we need to perform a while loop within the if statement. So basically here we are checking whether x equal to 1. If it is true, it will go to the inner block, which is a while statement, and perform the while block recursively until it returns false. So if the if statement is false, it will execute the else statement. So in this program, x equal to 1, so it will go to the if block and it will perform the while again, which is 1 is less than 3, and after this we just add z plus 4 and our x will get updated to 6. So the while loop got terminated and the final output will be z equal to 6, sorry, x equal to 6. So this is our intermediate code, and as we discussed, our expected output is 6. So I have executed several programs, the blocks within blocks, and also basic arithmetic operations. So this is how we have to execute our program. Thank you for watching.